Welcome everyone to 5.6 Inequalities in One Triangle. So this is a geometry concept extending the idea of triangles and angles and the related sides. Let's go ahead and start with the proof, everyone's favorite, proofs. Proof is in the pudding, they say. Comparison property of inequality. If A is equal to B plus C and C is greater than 0, then, okay, so what does this mean? Well, I'm going to be honest. This here proof is a long way of saying that a bigger number is bigger than a smaller number. So let's go ahead and get right into it. Here we have C is greater than 0. Anytime we're doing a proof, we want to start with the givens. Let me choose my color here. Let's go purple. So we're going to say this is given. Okay, now we go from the given. Anytime you have a given, you want to expand on that given. What can you do with that given? Well, we expanded upon it. We had C is greater than 0, and we added something to both sides. Well, if we add something to both sides, that's the addition property. I'm going to say prop of addition property. We're just going to say addition property, because technically this is inequality. Well, we can say equality. Addition property of equality. All right. So we have addition property of equality because we added B to both sides. Now we say B plus C is greater than B. That's the identity property of addition, okay? Because B plus 0 is just B. That's what this step is, okay? So B plus 0 is just B, identity property of addition. Now we have A equals B plus C. You're probably thinking, what? How did they come up with this? So you don't have to really worry about, in this course at least, you don't have to really worry about how you go from each step and proving things. That's in much higher mathematics, but just understanding what happens in each step is important. So we have B plus C is greater than B, then we go to A equals B plus C. Well, where'd that come from? Well, that was one of the givens. So this here will be given. Okay? Now, the last line is always what you're supposed to prove, so we know we can put A is greater than B, but why is that? Well, we can use substitution. What do we substitute? If A is equal to B plus C, then we can replace B plus C with A. Okay, so then we can say A is greater than B. Now, what is this a long way of saying? This is saying that anytime we have a number that's the sum of two other numbers, and C is not bigger than 0, that means it can't be a negative number. For example, let's take 7. 7 is equal to 5 plus 2. If 7 is equal to 5 plus 2, then 7 is definitely bigger than 5. That's all it's saying. If there's a sum of numbers, okay, a sum means addition, and it equals a larger number, then that larger number is going to be bigger than the two numbers separately. So it's going to be bigger than 5, and it's going to be bigger than 2. That's all it's saying. So 7 is bigger than 5, and 7 is bigger than 2. It's pretty obvious, but it's mathematically proven. So now you know. The corollary to the triangle exterior angle theorem. Okay, that's a mouthful right there. If angle 1 is an exterior angle, then what? What can we say? Then we can say that, well, we know this. This is one of our properties. What color should I make it? We know that the exterior angle sum theorem says that angle 1 equals angle 2 plus angle 3. So that's kind of like in the back of our mind as we're thinking about this. Okay, so what do we know? We know that angle 1 is going to be greater than angle 2. Okay, and what else? Angle 1 is also going to be greater than angle 3. I got too many colors here. Angle 3. So angle 1 is bigger than angle 2, and angle 1 is bigger than angle 3. There's a lot of little signs here. I'm just going to get rid of these angles. It's too messy. There we go. So 1 is greater than 2, and 1 is bigger than 3, because it's equal to the sum of them both, okay? Triangle side theorem. This one's important, okay? And this is a difficult concept to prove or to demonstrate virtually, but I'll do my best. Triangle side theorem says if xc is greater than xy, okay? So we have to identify, let's highlight these two sides first. So xz is this side right here. So this is xz. If it's bigger than xy, all right? So we got that. Then what else can we say? Well, we can say that angle z, well, let me put this on the right, actually, and start with angle y is going to be bigger than, what do you think? Angle Z. Okay, so angle Y is going to be bigger than angle Z. Now, why is that? Well, you see, the main principle to understand here is when we have a triangle, we have two sides that are like hinged. Well, let me undo that. There, got it. Okay. We have a hinge. So, let's say I have a triangle and it's got a very small angle. So, we're focusing here. Focus your attention on this little angle right there, okay? That small angle is going to result in a very small side, okay? So, right here. Now, what happens if I'm going to erase this again. What happens if I make this a bigger angle, okay? If I increase that green angle at the top, man, why did I make everything the same color? I'm going to make it yellow. How about that? Okay, so if I increase this yellow angle at the top, so focus on the yellow angle, okay, small, okay, again, that was small, and I open this up to a wider angle now, what happened to that opposite side? This opposite side grew. I kept the length of this blue side the same, okay, both these sides stayed the same length. I just adjusted this angle, and this green side grew. Okay, so the angle really controls the side, the opposite of it, whether it's big or it's small. So let me show another example. Okay, I'm going to do it again. Okay, so here we have small angle. Okay, whoops, it's kind of tricky with this. Okay, so small angle, I increase it, keeping the side length the same. Okay, now I'm obtuse. Notice how it really opened things up. So the bigger the angle, okay, the bigger this is, the bigger the opposite side is going to be. So that's true here. If we draw a triangle and we keep this side the same length and the other side is the same length, and if we can compare the sides, and if the blue side is bigger, then the blue angle is bigger. If the red side is bigger, then the red angle is bigger in terms of this diagram, okay? The opposite angle, these angles, control the side opposite of them, okay? Think of your arms. If you move your arms, you keep them straight out. The more you lift your arms up and control that angle by keeping one out straight in front of you and raise the other one up, okay? This is what I'm doing with my arms. You can't see because I'm doing it right now, but you can't see. So if you raise your arms up, as this arm goes up, the distance between the two hands, your arms are going to stay the same length, okay? They're not going to grow or increase, but as you increase that angle, the distance between the two arms increases. That's all this theorem's saying, okay? So now we're going to talk about the converse after I got done lecturing for about 20 minutes. The converse of triangle side theorem. If the angle x is bigger than angle z, okay, so here we have this triangle, okay, angle x bigger than angle z, then what do you think? Well, first off, let's change this to a y. I don't know why that's not a y. Change this to a y. Let's make it a purple y. Okay. If angle x is bigger than angle z, then we know that the side opposite it, okay, so that's this side. X controls this angle, controls that side. So we know that zy, that side, is going to be bigger than the side opposite z. The side opposite z, the one that its arms control, is this one, this blue side, and that's xy. So the bigger the angle, the bigger the side. The bigger the side, the bigger the angle. So it's the converse. That's all it means. Thank you, Woodstock, for showing us that. Okay, moving on to the next thing, triangle inequality theorem. I don't want to spend too much more time jibber-jabbing, so hopefully we'll be done soon. Triangle inequality theorem. The sum of the lengths of any two sides is always greater than the third. Okay, this is true of any triangle. Otherwise, it's not a triangle. So xy plus yz needs to be greater than xz. Okay, what other things can we say? We could say yz plus, I'm going to be changing my colors a lot here, xz is going to be bigger than xy. Okay, let me get this one set up. What's the other combination we haven't done? Well, we can do xy plus xz is going to be bigger than YZ. Okay, so any two sides added together needs to be bigger than the third side. So these two sides added together need to be bigger than the third side. These two sides, okay, you get it. It's going to be bigger than this side, you get it. All right, so that's all there is to that one. Now, the way we can apply this is we can figure out if we can form a triangle with certain sides. So let's look at example 1. Can a triangle have sides with the given lengths? 3 feet, 7 feet, 8 feet. What we have to do here is we have to see, can we add 3 plus 7 and have it be bigger than 8? Question mark. Can we have 7 plus 8 and have it be bigger than 3? Question mark. And can we have 8 plus 3 and have it be bigger than 7? The answer here, let me go, I like these colors better. The answer here is yes, yes, and yes, okay? So all three of those true. This is 10 is greater than 8, this is 15 greater than 3, and this is 11 greater than 7. So a triangle can be formed with this. Okay, let's look at the next one. We can do 5 plus 10, is it bigger than 15? Is, question mark, is 10 plus 15 bigger than 5? And is 15 plus 5 bigger than 10? Okay, question mark, question mark. Here we see that it's yes, yes, and no. Just one of these is grounds enough to say that a triangle cannot be formed. And why is that? Well, imagine that we have this 15-foot length here. And then we have this little itty-bitty 5-foot length. Okay? And then we have our third side, which is 10 feet. It's not going to reach the 15-foot. Because if we laid this all down flat, okay, let me change the color. We're gonna lay these down flat in just a second. And I'm gonna show you that in order to get it to touch the other side, it would have to be directly on top of it and form a line. Okay, just like that. Boom. That's not a triangle. That's what it would look like. It would just look like a line. So that is not a triangle. Okay, and that is one of the first properties we can do. Now, the second way we can apply these principles is example 2. We can look at a situation like this and identify which side is the longest, which angle is the smallest, etc. We can identify pieces of information even if we don't know it. So I'm looking at this and I say, which side is the longest? Well, first thing I know is I don't have any angles inside the triangle, so I should probably do a little bit of math. I know this is supplementary, so I know that needs to be added to something to give me 180, and that something is 95 degrees. Okay, so I have one angle inside the triangle, and it is 95 degrees. Okay, now, what other piece of information I need to know? Well, if it's triangle and we have one angle equal to 95, then there's no angle that can be bigger than that. Okay, this can't be 96, because guess what? That adds up to bigger than 180. Okay, this one can't be equal to it, because guess what? That adds up to bigger than 180. So I know these two angles right here are smaller than angle A. So I know that the longest side is going to be the side opposite than 95 degrees, which is this side right here. Okay, so that is going to be the longest side, and that is BC. I'm going to write it in green, BC. You can put a segment on top, that's fine. Which angle is the smallest? Well, now that I know this one's the longest, I know angle A is out of contention. It's not going to be the smallest. Now, I don't need to know the actual measurement. I just need to know which one is smaller. Okay, so I have this angle B. B controls this side right here. And then I have angle C, and C controls this side. Well, take a look. The opposite side of C is 4, and the opposite side of B is 5. So clearly C needs to be smaller because it has the smallest side in the triangle. So C is the smallest angle. Can BC have a length of 10? Okay, so let's find BC. BC have a length of 10. Well, now we need to apply the principle here. 10, question mark. Can these add up to give us the appropriate side length? So can 4 plus 5, is that bigger than 10? And already that's a problem. 4 plus 5 is 9, and 9 is not greater than 10. So it could not be 10. That's no. Because 4 plus 5 is not bigger than 10. Even though 10 plus 5 is bigger than 4, and even though 10 plus 4 is bigger than 5, because 4 plus 5 is not bigger than 10, this cannot be a triangle with a side length of 10 inches. So that's a no. Okay, stay tuned for next time. We're going to talk about inequalities in two triangles. That's twice the excitement. Can't wait to see you there.